We're looking at orders of operation today. We have PEMDAS. If you remember that, please excuse my dear Aunt Sally. Parentheses, exponent, multiplying, dividing, adding, subtracting. That's a recap there. Examples of orders of operation. We have an exponent here first that we need to take care of. So we go 3 times 2 plus 2 cubed is 8. Then we move on to multiplication. 6 plus 8. And then we wrap up the problem. Ends up becoming 14. We have that one to start us out. Next one. We have 2 times 8 plus 1 times 6 squared plus 8. You start with the exponent first. So it'll be 2 times 8 plus 1 times 36 plus 8. This one we have multiplication in a couple spots. 2 times 8, we get 16. 1 times 36, we get 36. So we have that down the line. 16 plus 36 plus 8. It's all addition. It's all the same thing. So we just go ahead and add straight across. That ends up being 60. Last one. We have 6 times 2, or 6 squared plus 27 in parentheses, and then over 3 squared. So we start inside the parentheses, but inside these parentheses, we have an exponent. So we go ahead and take care of that. Parentheses have not gone away yet, technically. So I'm still working up top. 36 plus 27 is 63. Over 3 squared. 3 squared is 9. So 63 divided by 9, which ends up being 7. We have that. Next thing we're doing today is words to expressions. We have keywords and phrases that we're looking at. Take a second to check those out. These are keywords for the operations that we're using for addition, subtraction, multiplication, division. So I'm going to give you a phrase, as you see here, and we need to write it into math terms. So 6 is decreased by a number. Decrease means subtraction. So 6 is decreased by a number. We're subtracting a number from 6. So we'll call that number x. It can be any variable you want. There's your expression. Same deal here. Product we saw in the last slide is multiplication. Product of 3 and a number is just 3 times x. 3 times a number. That variable can be anything you want. 5 more than a number. We have addition. We have a number, and then we're going to add 5 to it. 5 more than that number. That's what we have there. Last one. We have quotient. That's really the only one that you're going to see when we're talking about dividing. Quotient of a number and 7, so it would be a number. I'll call it n this time just because n divided by 7. So that. Now, same deal. It's just we have more things going on. The cube of twice a number. Twice a number means 2 times a number. So we have that. But we're taking the cube of that. So the whole thing needs to be in parentheses here. We have 5 more than the square of a number. More than we saw in the last slide means addition. Square, similar to what we saw in the last problem, is going to be an exponent. So 5 more than the square of a number. A number is being squared. And then we're going to add 5 to it. So we have x squared plus 5. Next. 2 more on the slide. 4 less than the product of 7 and a number. So we have less than, which is subtraction. Product is multiplication. We're finding the product of 7 and a number. So it's 7x. And we're looking at 4 less than that. So we're going to actually subtract 4 from there. Last one. 6 minus 3 times the number. Minus, I think that one's obvious, subtraction. 3 times the number, so it'd be 6. minus 3 times a number. So you have that. Evaluating expressions. I'm going to let 3 variables equal something. All we're going to do is plug it in. So I have 4x plus 9. X equals 5 here, so I take that 5, plug it in for x. 4 times 5 plus 9. 4 times 5 is 20. Plus 9 equals 29. So you have that one. Take that away. We're not using that in the next one. Next one, we just have z. So we're going to take z. We're going to do the same thing. Plug it in to both spots this time, though. So z was 2. So we go 3 times 2 squared minus 6 times 2 plus 5. Orders of operation come into play. Exponents first, so it'll be 3 times 4 minus 6 times 2 plus 5. We have multiplication in a couple spots. 3 times 4 is 12. 6 times 2 is also 12. So we have 12 minus 12 plus 5. 12s are gone. Answer is just 5. Okay. Combining like terms. Like terms need to have the same variable and the same exponent. You got some examples there. Check marks those are like terms. X's are for ones that are not like terms, obviously. So let's check a couple of these out. Got a couple of examples here. We got different terms. I like to box them in. So I have a constant. We find other constants. 6 and 3 are constants, and we have a -5, a -5 here. All right, so 6 plus 3 minus 5, we end up getting 4. So I move on from there. I can cross those out if you want and see what we got next. I got y's next. -7y and then a plus 4y. That becomes -3y. So the y's are done. And then lastly, I have the x cubes left. -4x cubed plus 2x cubed is -2x cubed. I've combined all the like terms I have. Same deal with this next one. Last one. Just go left to right to start us out. We're just adding and subtracting here. Combine like terms. You have a 2x minus an x, and that's it for the x's, so that's just 1x. If you want to put a 1 there, go for it. I have constants. Well, those constants are right next to each other, so we're good. Ends up being plus 7. 6 minus 2 is 4. 4 plus 3 is 7. So those are all done. We move on to the end here. Plus a 3x squared.